So, thanks very much for having me tonight. My name is Falk Bleyl. I'm CTO at Utopi. We're a new business. We've been around for about 3 years, and we work actually on in-building technology. So some of the things that were covered earlier on, I want to talk about a little bit and actually give you a specific example of numbers. I find numbers fascinating. I don't know about you, but average is one of those things that I like to look at and think there's something hidden behind those averages, and we'll cover that in a minute. So Utopi as a company is in the business of making data in managed residential buildings, so that is purpose-built student accommodation and built to rent, but also other residential market segments, make that data visible to the operator and also to the residents within those buildings. Typically, residential buildings for the operator are black boxes, and except for the odd visit, inspection once a year or whatever, they don't know how that particular space is performing. So very much like what you said earlier on. And we're in the business of actually making that come alive. So we gather the data, and we gather the data through a variety of different technologies, in-room multi-sensors that gather a variety of different metrics, but also utility consumption data. So that is typically electricity. In some cases, it's also heat, and in some cases, it's also water. And bringing those data points together provides an incredibly rich data set that allows you to actually understand what's going on and also to help manage what's going on. And that, again, that is both for the operator on the one hand and for the resident on the other. So the kinds of devices that we use for the data collection include smart meters that are retrofitted in buildings. In some cases, it is smart meters that already are data connected to a data logger or other device or BMS, and then can present that data. But in some cases, buildings are fitted with the standard types of smart meters that people have in individual homes also, and we can extract that data from there also. And then basically, once we gather that information, and just to give you an idea, we gather about 1,000 data points per apartment per day. With that kind of data set, you are then able to actually do certain things with it. So we analyze that data. We can see, for example, if there is unexpected utility consumption in a space that is supposed to be empty. And through those kinds of things, we have seen electric towel rails that have been left on, leaking toilet cisterns, water taps that were left on, other systems that just didn't work properly to specification. We've seen overheating in buildings through solar gain, very topical situation today at the moment, where we've actually seen those kinds of things, and we've worked with operators to try and mitigate those kinds of things. We can provide alerts. So when you see unexpected performance, and that may even be high humidity, where you have people perhaps using the tumble dryer to heat their apartments and things like that, and just having damp air, warm air, thankfully being blown into the room, that we can spot those kinds of things and set alerts. And then we can report on those things to the operator on the one hand, and we can also have engagement with the residents. And we have a resident app that allows us to then basically go and let a resident know how their space performs, both in terms of well-being metrics when it comes to, again, temperature, humidity, air quality, and even like noise and light levels as well. They can see those kinds of things, and they can also see their energy consumption over that period of time. And we can push messages to residents on the app to help them understand how they perform in relation to others within the building, and also how their performance compares to their previous weeks or months' performance. So where do averages come in? If you take a normal building today, and student accommodation is a great typical example for that, because student accommodation, when it was first built, had a main meter for electricity. The apartments are heated with electric panel heaters in many cases. I know there are exceptions or differences now, but that's what the situation is like. Because student accommodation is typically offered on an all-you-can-eat tariff, so the electricity costs are rolled into the rent. So students are not aware, but the building operator isn't aware either, because there's no metering in place to actually allow you to get that kind of data out. So if you take a building like that and you say, right, okay, what's the energy consumption in January? You will all know that the consumption within a building varies over the season. So you would expect, as you come out of the winter, go to spring and into summer, for that to actually decrease, and then as the year turns, basically it goes back up again. So here you can see that an average monthly consumption is hardly ever reached, or there may be 1 or 2 months in the year where you're kind of round about there, but typically you have times where you go beyond that, and then times where you are below those kinds of values also. So if you take the same thing and you say, right, okay, in January, let's say I have 200 or 300 student apartments in a particular building. This is my total consumption. I just divvy it up into 200 or 300 equal portions, and that's my average consumption per student. That is absolutely not the case. And some of these numbers I'm going to show you now are real numbers from real students over the last year. Okay, so if you took the average and you basically had that across the piece, and you compared that to real consumption, you have some that stick out significantly above that, and you have some that are significantly below that. Now, how do you manage that if you don't know on an individual apartment basis what the actual consumption is? So firstly, you can't manage what you can't measure. Therefore, the measurement provides you the actual evidence and the detail. Now, in this kind of a scenario, there's only one who kind of, used the average. But just in the same way that at one point I was average height and average weight, I'm still average height, but the average weight bit is going. In the same way, we have the same kinds of situation here, where there is such a big difference. And the variability is such that it's extreme. And it's extreme, and it's compounded really by today's energy costs. So if you assume a rate of 18 pence per kilowatt hour, the difference between the highest spender and the lowest spender in one heating season is about £1,650. Okay, and that is the cost, just the cost of electricity for a one-bedroom student apartment, compared to a similar one in the same building with the same aspect, the same floor area, and so on. And those students, even at the lowest end, were not shivering in the cold, and it's not that they weren't there. Because of the other data that we have from the census, we know that they were living in a comfortable environment, that they were there. It's just that they used their heating system differently. Rather than having two kilowatt panel heaters switched on all the time during the winter, and opening the window to heat Scotland, which I really appreciate as an effort, but it's not environmentally sensitive or sensible. But with that, for an operator, this is absolutely critical to know. And then the question is, how do you get those excessive spenders to proper levels? And if you do that, you save. If you just take the outliers and you bring them below the previous average, you drop the average altogether, with that, you are then able to actually, move the needle, so to speak. And basically, the data gathered from our census and the resident app can help letting people know what is actually going on and what they're actually doing. And then with that, making them aware, that effectively they're contributing from a carbon point of view, really. And if they want to be more environmentally conscious, we give them hints and tips on the resident app to actually reduce this. And then if you add to that control, and at a student accommodation level, that can be difficult as a retrofit, but we have done it. Then you're able to actually move the needle even further. So if we manage to get everybody to about the average between the two lowest users in this example, we drop the costs of electricity and actually the consumption to about 2/3, or by about 2/3 from the original numbers. And that gets us very close to those target figures that you mentioned. So they were music to my ears. And then, you know, this part, then as far as the control is concerned, helps to actually bring the average down, but in reality, it helps bring those outliers in every case. And so I've used electricity as just one example where, by looking at the big average for a building, you don't actually get to understand what's going on. Only if you look at the granular level, and if you look at the granular level with some further context, is it actually possible to reduce those kinds of numbers. And then really for us, the next step, and we're going through that development at the moment, is that we then allow some co-management so that there are certain parameters within which a student can operate, you know, a heating system or so, but at the same time that the operator can override it, in the sense that if a student has set the temperature to 21 degrees, there's a way for the Christmas period that effectively, you know, with the sensor realizing that nobody's in the room, that the temperature can actually be brought down to another level and actually stop the waste of energy. And so I hope this gives you an idea as to what can be done if you look at averages, you disaggregate it, you find the detail, and then you can work on those outliers to actually bring things together. And that, we believe, is one of the key ways as to how we can actually start moving the needle as far as consumption is concerned. It is by looking at the detail rather than the averages. Thank you.